All right, let's get started. Uh, Good morning, good evening, everyone. Welcome back again. So, just quickly recap what we covered yesterday in 5-10 minutes, and then we'll continue from the further discussion. Some of the topics on this database course, some of the basics and architecture part, and some questions and answers. All those we can cover it today. So, we started yesterday with the introduction about your instructor, that is me. I'm the one who is going to take this course. I just briefed about my overall experience and my areas of expertise and what are the major projects and which all organization I worked. And then followed by we briefly went through about entire course curriculum or course structures, and here is the course curriculum. So feel free to go over this course curriculum once again. So I'm gonna post these links in the chat here. If anyone missed, you can take a note of that. So this is about the course curriculum link. You can check it over here. And in case if you're unable to attend and you want to look for some other future dates, you can take a look on this second link here in my blog. So I'll be keep posting the upcoming batch details. So database course we are starting from Monday, and then RAC is coming up in the next. That's a second link, upcoming batch details. And briefly, we talked about the course fee structures and timings. So as we talk yesterday and today, 19th December and 20th December in IST time zone, Thursday, Friday, 8:30 a.m. IST to 10:30 a.m. That's India time zone where we are conducting these demo sessions, and these are for EST time zone, 18 December and 19 December, Wednesday and Thursday, 10 p.m. to 12 a.m. And this is the Zoom link, what we're using it for the demo session. And then actual course is starting on coming Monday. Monday onwards, we'll be starting the actual course in IST time zone. The timing is going to be 8:30 to 10:30. For EST time zone, it will be on Sunday, 22nd December, 10 p.m. to 12 a.m. EST. So other important factors about the course is this is a weekday batch, Monday to Friday, 8:30 a.m. IST to 10:30 a.m. IST, Monday to Friday, 2 hours every day. And within 35 days, 40 days, we'll be able to complete this course. So in EST time zone, it will be 1 day behind. Instead of Monday to Friday, it will be Sunday to Thursday at 10 p.m. EST to 12 a.m. EST, every day 2 hours. And the 35 to 40 days we can able to complete. And this is the paid training. The course fee is 10,000 Indian rupees or 125 US dollar. It will be conducted via Zoom session. And we're going to cover 19C Oracle version. So the registered student will be getting access on the Google Drive, the course materials, and other information. Hopefully, like who are got registered from last 1 week, they're all part of the WhatsApp group and they all got the Google Drive access. Just to take a look on the Google Drive access, so we'll be having the Google Drive link one where you can see all the course materials and all the ready VMs, ready lab setup, and the second Google Drive link other information where you can see some softwares and some of the interview questions and answers and other tools and some of the monitoring script and automation script. So you can get it on the second link. And the third link where you can see a previous batch recordings, where the previous batch recordings, whatever the sessions conducted, the sessions will be recorded and you can watch the previous batch recording in a fast track manner by your own pace. And Along with recordings, you have the notepad. Whatever I am demonstrating in the lab exercise, all will be captured in a command line here. While watching the session, you can copy paste this command line and you can practice in your lab. So all the sessions, notepads, recordings will be uploaded here. So you can watch these recordings well in advance before attending the live classes so that you can ask more questions and make the session interactive. And the third link and the fourth link, current batch recordings. Whatever we are doing these sessions, live sessions will be recorded and will be uploaded. This is my yesterday session and then I uploaded. And along with that, whatever the notepad I'm generating, all those will be uploaded along with the recording so that whenever you are referring or rewatching or revisiting these sessions, you can practice it by referring to this associated notepad. Right, so those are the four Google Drive links, what you will be getting it. Again, these are lifetime accessible, no restriction. Even you can download it to your local laptop, no restriction on that. And then who are got registered from last 1 week, they all got this Google access and they are all part of the WhatsApp group. So any questions, queries, or any doubts, any concerns, all will be discussed on this WhatsApp group. That's the primary way of communication. And it may be related to this particular course, queries, questions, or even you are working for any organization and you need some help and some of the activities or tasks you are stuck, you are facing some challenges. Feel free to take just a screenshot, post it in a WhatsApp group, and anyone can answer, or I can connect with you to unblock you and help you on particular issues. Or you are having some upcoming interview and you want to prepare yourself, you can feel free to post your questions, queries over there, or you can call me on my WhatsApp number or cell number. Or you recently attended some interview and some of the challenging questions you are unable to answer, feel free to post those questions. I'll be able to answer those questions. Right, so that is a primary way of communication. We're going to use this WhatsApp group. And again, this is only for the registered student. Again, this WhatsApp group also for the lifetime access. Even after completion of this course, this group will be active and you can use that for any discussion, any technical stuff. Whatever the queries and questions, we'll use this WhatsApp group. Right, and then post our yesterday sessions, many of the students are pinging me on my WhatsApp number and had a communication with me and I guided them for the further payment process. So again, I'm gonna posting this WhatsApp number and cell number in the chat here. You can take a note of that and feel free to ping me and call me on my cell number or WhatsApp number so I can further guide you through further payment process. And these are my WhatsApp number or cell number. Take a note on that. And then on top of that, we discussed about what are the minimum prerequisites, very, very important. So this course is made for anyone. If you are new to this IT field or you're switching your domain from other domain to this DBA domain, or you're already having 1 year experience, 3 year experience, 5 year experience, or you're already having 10 years of experience, you want to brush up the knowledge. So anyone can attend this course because this course is made up of from beginner till advanced level and no restriction that anyone can attend this course. So if you're having a basics of Windows, Linux, SQLs, so that's a added add-on to this. And if not, along the course, you have to learn all of these skills. So whatever needed for this particular DBA course will be covering on daily sessions, all the basic Linux commands and the queries. So we have this Linux and SQL query, some basics, no, basic nodes on our Google Drive, where you can go ahead and brush up your knowledge. For example, if I go here on the Google Drive link one, so if I can go to this SQLs, so we have basic notes on the SQLs. So you can go and then watch these basic notes on the SQL, and this is going to help you to make you stronger, better in the SQL basics. Likewise, we have related to Linux and other stuff. So we have to put some extra effort to use to it and then be expert on this basic understanding of Linux and SQL so that the database course or the DBA commands are going to be easy for you. If you don't practice and don't enhance your skill on this SQL or Linux commands, so a DBA course is going to be a little difficult. That's why you have to put some extra effort and then be in phase with what I'm teaching. Right. On top of that, one other important prerequisite is hardware. So you should have minimum 10 GB RAM and minimum 100 GB SSD hard disk so that you can set up your own lab on your laptop and you can practice it. If you don't have this RAM and you don't have this hard disk requirement, so you will be able to attend the course and you'll be able to listen and you'll be able to see what demonstration I'm doing, but you will not be able to do your own hands-on experience. So for that, the hardware requirement is must. So along the way, how I'm doing the setup, you will be doing the setup on your own lab, on your laptop or desktop. For that, we need a minimum of this much of RAM. So I got a couple of questions after yesterday's sessions. I have only 8 GB RAM, I have 6 GB RAM. What can I do? So you have to upgrade your RAM or you have to change your laptop. So even with the 8 GB RAM, 6 GB RAM, you try to configure VM and try to do a lab exercise, you may end up with your VMs getting crashed and your installation getting hang, your laptop getting hang. So those all issues will going to be faced. So for that, you should have minimum hardware requirement before proceeding with this course. And if you're okay that I'm planning to buy laptop, I'm planning to upgrade my RAM in next few months. Now I'm okay to listen the course and I want to, you know, prepare myself. So feel free to join this course, no worries. But until you do hands-on experience, you'll not be able to get the confidence or gain the confidence in the interview or gain the confidence level to crack the interview. Right. So that's prerequisites what we discussed. That's all. And then on top of that, we spend a lot of time um, in covering the course curriculum in details, and also we covered pretty much most of the questions what we face in the interview along the each topic in RMAN, in backup and recovery, in patching, in upgradation, in data guard, and in user management, in database, in architecture. What are the expected questions? So all we discussed in yesterday's session, right? So that's all what we discussed. Now let's continue today. So we'll start with some basic understanding or basic architecture, some networking, some RAC, and standalone database. We'll discuss this technical stuff now. So before I go with this a technical discussion, so I'll give a pause for a minute if anyone has any questions so far or any recent interview faced some of the questions. Feel free to ask. We'll make it interactive rather than I start explaining and you guys are listening. Just uh, throw some questions. We'll see if it is some basics, and then we'll discuss them, and then we'll go with some technical discussion.
Hi, Mallikarjun.
Hey,
My name is Sai Pranav. I am attending your class for the first time today. I missed your class yesterday. So I had a couple of questions I wanted to ask before we get into the database architecture and stuff. Um, so one my main question is with regards to setting up the VM. Has that already been done in the previous class?
You are breaking up, Mallikarjun, like yesterday.
is it better now?
Yes.
Okay,
Yeah.
so you attended yesterday, then you could understand. So that's the first chapter. What we're gonna do that. on Monday when we start a regular class, and
So the
we'll do
installation is
lab
going to be
session.
done Monday. Okay.
Yes.
Sorry. Uh, Another question. So I stay in New Jersey. I was wondering if you had any payment options for Zelle, or how would you like? I don't have.
Yeah, that we'll take it offline. So you can ping me on my WhatsApp number. There are a couple of options I can guide you through how you can proceed with the payment and registration. There's the other thing I can guide you through the process.
Okay. Thank you. That's all I have.
All right. All right. So any other questions, guys, before I start with some discussion? Anything on the course content or the payment process or the any challenges or any doubts or any concerns? Feel free to ask the questions. You can unmute yourself or you can use this chat box here. I got one chat here. If the laptop RAM is not up to the requirement, can we use some external disk or the work? Yeah, as long as you have any external server you have access, feel free to use that one. That works fine. But if you have a one laptop with a minimum 32 GB RAM, so you can easily work on both the RAC, both database and your OEM Golden Gate. So with 32 GB RAM, you can play around that. There's other question, is recording class available after the class? Yes. So as I told yesterday, so every day sessions will be recorded and uploaded immediately after the class completion. In case if you are unable to attend today's class, you can feel free to watch the recorded session. That will be available immediately after the class completion every day. So you can see this is yesterday's sessions I uploaded immediately after the class completion. So, and not only the live sessions, you have the access on the previous batch recording. Again, these are the same recordings. You can watch them well in advance, like kind of a fast track, and you can prepare yourself before attending the live classes. All right. So with that, I can proceed further now. Let's discuss some topics, some basic understanding. So let's say very first topic I'll talk about the database architecture. So one of the most commonly asked interview questions, can you brief or can you explain about database architecture? So a database architecture, the moment this question asked, like, in any interview, if you go, the first question they'll ask, can you brief about database architecture, how database architecture works? Many people will get confused where to start. So they will start with the end users are connecting and listener will take that connection and they will allow to connect to database. So we should not talk about end user connection and all at this point. So the moment they ask what is database architecture, so our question, a database architecture is a combination of instance and a database. So instance is the logical structure and database is a physical structure. Instance is a logical structure which is a combination of memory and the background process. Database is a physical structure or the physical files or the OS files or the data files or the storage files. So combination of your instance and database will make your entire database architecture. So as I told, instance is a logical structure and database is a physical structure. So if I further divide what exactly instance is, so instance is a memory and background process together will form my a database instance. And in the memory again, you have SGA and PGA. SGA is a shared global area or the system global area. PGA is a private global area or program global area. And again, if you go further inside, you have SGA, so many sub memory component. like shared pool, large pool, Java pool, database buffer cache, and redo buffer cache, and stream pool. And inside PGA, you have UGA, stack space, sort area, temp area, bitmap area, cursor area. So those are memory component. Remember, again, I'll repeat one more time. The moment they ask what is database instance or what is database architecture, or can you brief me about database architecture, we have to start with the instance and database. Instance is the logical structure and database is a physical structure. So instance is a logical structure which is made up of memory and background process. That memory again made up of SGA and PGA, and that SGA and memory PGA memory component are made up of so many sub memory component. And then the other background process which is part of my instance has some mandatory background process and some non-mandatory background process. If I can expand here, right? So in the background process, which is part of the instance, which has a mandatory background process and non-mandatory background process. So in mandatory background process, you have smon, pmon, dbwriter, logwriter, checkpointer, and non-mandatory background process are like archiver, recover, job queue process, mon, mnll, and etc. So many. So if you are able to explain this much, that's more than enough. And then that is only part I explained about the instance. That's the first part of your database architecture. What is database? Database is your physical structure, which are physical files or OS files. That will be described as in this manner. Your database is a backend storage or end user data or data files or physical files or the storage files, which are nothing but system, sysocs, undo, user, temp data files. So that is what you need to explain when they ask about database architecture. So this is one of the common question in the most of the interview. What is database instance? What is database? What is database architecture? Can you brief about database architecture? If they don't ask about this database architecture, what they will ask? What is SGA? What is PGA? What is shared pool? What is large pool? What is Java pool? What is database buffer cache? What is redo buffer cache? What is stream pool? And what smon will do? What pmon will do? What dbwriter will do? What logwriter will do? What checkpoint will do? And what's the use of system data file? What's the systoc data files? What's the use of undo data file? They'll ask about each of these questions on this instance or the database level or this background process level or this memory level, or they will ask you to brief about database architecture. Again, each of this topic, if I start explaining it, they're going to take 5 to 10 minutes. So that will not be enough for 1 or 2 days. So this is your entire database architecture. So as a DBA, you should be very, very strong on explaining each and every concept of this, each and every definition of this, and each and every background process and its associated job, and each and every memory component and its associated job. You should be able to explain without any hesitation and without any other thought. So even in the middle of the night, somebody wake you up and then ask about this architecture, you should be able to explain each and every component in detail. So once you are strong at this particular fundamental architecture and remaining all advanced topic, whatever you call it as a data guard, OEM, RAC, Golden Gate, all will be very easy for you to enhance your skill sets. And also you should be able to demonstrate in a picture view or a diagrammatic view if they ask you to draw this particular architecture. So I can quickly show you that by just drawing how we can illustrate. So let's make it bigger here. Okay. This is my instance. So this instance plus backend database. Instance plus backend database. So database is nothing but your data files. I'll just mention data files. And these data files are nothing but system, sysocs, undo, user, temp, whatever I just explained here. Right, let's say here. So these are your backend database, the data files, and then this is your instance. So your instance is a memory and background process. So if I go back here, so I can divide this one. This is my instance. So this is my memory and this is my background process. So in that background process, I talked about smon, I talked about pmon, I talked about deburator, I talked about logrator, I talked about checkpointer. So these are my mandatory background process: smon, pmon, deburator, logrator, checkpointer. And there are some other non-mandatory background process: archiver, recoverer, and all those things. And then we have a memory component. I'll talk about database, buffer, cache. Then I talk about log, buffer, cache. I talked about shared pool. So three major components which are heavily used in my instance are shared pool and database buffer cache and redo buffer cache. We have this stream pool, we have this Java pool, and we have this large pool, and very limited use. But best example is large pool is used for heavy IO activities, your RMAN backup, your export import, and your SQL loader job. Your large pool will be used. And your stream pool, if you have any golden gate, your table level replication, the stream pool will be used. And the Java pool, if your application uses Java code, JVM virtual machine, and your Java pool will be used. So these three are very limited used in the instance memory component, and remaining all your shared pool, database buffer cache, and redo buffer cache are used heavily in my database for each and every transaction. Right. And then let's remove this. Okay. And then let's say how this transaction work now. So along with this memory, this is my SGA, which is part of my memory. And also we have PGA, the other memory component. Let's say I have a user one trying to connect to my database. This entire section become my database architecture. So let's say the user one trying to connect to my database, and this user has no way access to my data files or the database or storage. Any user, if there is 100 users, 1000 users, or 1 million users trying to connect, all the connection will go to my instance. They had to connect to instance. Whatever this query they're doing, the end users may be doing some insert queries or some update queries or some delete queries or some create queries. Whatever the query they're doing it, all they have to connect to my instance first, and they have to do their transaction at my instance, and later the transaction will go to my database. So now let's say this end user is connected, and that end user will connect, and there will be one server process will be started for him, and then that server process will be attached to that particular PGA. Let's say there's a one more user trying to connect to my database, and then one more server process will be started, and one more PGA memory component will be allocated. And there's a one more user trying to connect to my database, and then one more server process will be started, and one more PGA memory component will be allocated. And remember, by this you should understand these PGA components are user specific. If there's 1000 users connected, there's 1000 PGA memory will be allocated. And because of that reason, I mentioned here, right, where that here, a PGA is nothing but private global area or program global area. Why it is private? Because if there's a users are connected, three PGA memory component. If there's 100 user connected, there's 100 memory component for PGA. Each PGAs are private to that particular single user. I talked about SGA is a shared global area or the system global area. Why it is shared? Because even though you here three users are connected, they got a three PGA. All those three users are going to access single SGA. The SGA is shared and PGA is a private one that is user specific. And then each of those users, whatever connect to my database, they'll be having their own server process. And any users, they do their transaction. Let's say this user is doing select query. This user is doing some insert query. This user is doing some update query. The select, insert, update queries, whatever these users can run, that queries are taken over by the server process, and this server process are going to execute inside my SGA. Whether it's a select query, whether it's insert query, whether it's update query, all will be executed inside my SGA. And only three memory components are heavily used for each and every queries. Whether end user can do insert, end user can do update, end user can do any delete or create, whatever transaction they do, the main component will be used is your server process. So server process is going to use your shared pool, database buffer cache, and log buffer cache. Again, I'm not going to talk in detail about what is server process, how it will be used, and in a simple definition, this server process has your library cache and your data dictionary cache. And in the memory component, in the database buffer cache, we have a pinned buffer, we have dirty buffer, we have free buffer. And then in the log buffer cache, whatever the redo vectors, whatever the change vectors, or whatever the transaction information, all will be stored under this particular log buffer cache based upon what kind of a query they're doing it. And then we have this mandatory background process. We have this DB writer. Whatever the data is written on this database buffer cache, the data will be written to my data files with the help of my DB writer. Whatever the transaction information written on my log buffer cache, my log writer background process will take that transaction information and write into my redo logs. Redo log 1, redo log 2, and redo log 3. Whatever the redo log we have it on physical storage, my redo log writer is going to take that content of log buffer cache and write it into my redo logs. Again, in our actual class, we'll explain in detail about what is this transaction information, what is this log buffer, what it contains, how this log writer is going to write it, how frequently it's going to write it. There are some condition every 3 seconds, 1/3 is full, when your checkpoint occurs, when your commit happens. So all those in details we'll discuss in our regular classes. But in a simple definition, anyone ask about the database architecture, you should be able to draw this picture and you should be able to explain this one. And once you're able to explain this concept, and that indicates how confident you are at your database skill set. Once this particular architecture or fundamental concepts are clear and you're strong at this one, you should be able to enhance your skill set and easily learn other advanced topics like RAC and Golden Gate and Data Guard and other stuff. Right, so that's a quick overview of the database architecture. And again, I have not covered complete things, but if you're able to demonstrate this and able to answer to that question, and that is fair enough, or that is more than enough for any interviewer. So if I can quickly show it on my lab here. So I have a database called a DaviDB. These are my background process here, whatever I talked about. So this background process, a PMON is a mandatory background process. And we have this log writer, we have this DB writer, we have this checkpointer, we have this SMON. These are a mandatory background process. If any of these background processes are killed, your database instance will go down. Along with that mandatory background process, we have other background process like recoverer and archiver and your job queue process and your M1, MMNL. So these are other non-mandatory background process. If you kill any of these non-mandatory background process, these will be automatically get started. Your database instance will gonna start these processes. But if you kill any of these mandatory background process, what I just talked here, the log writer, smon, and db writer, pmon, so your instance will go down. For example, I can kill one of the mandatory background process. Let's say I'm going to kill one of the mandatory background process. Let's take a pmon, or let's take smon. The smon is here, and the process ID is 5560. I'm going to kill it using a OS command. Kill -9. The moment I kill, and then if I try to connect to database, it says connected to idle instance, meaning your instance went down. It is idle state now. Your instance is down now. So if I run the same command, all the background process will be stopped. Now nothing is running. So nobody can able to connect to my database now. My instance is down because I killed one of the mandatory background process. So now any user, as I just mentioned here, any of these user 1, user 2, user 3, if they want to access my database, this database are nothing but data file. End user data is under this data file. Whatever the table they created, whatever the information they created, all will be stored under this data files. If they want to access the data files, whatever the data they stored, they have to connect to instance. If the instance is not available, nobody can able to connect to this database. So for example, my database is here. I showed yesterday. I'll go to yesterday's log. So these are my data files here. Whatever I showed yesterday, select star from data file. This is your end user data here. System, sysocks, users, and undo. So if I can go to this location, exit, cd into that, lsf filter. I have all the data files. I have all the end user data here. But end user will not be able to access this data, which is available on these data files. Because they have to first connect to instance, and whatever the query they're doing, whatever transaction they're doing, they have to do it from instance. My instance itself is down now because the mandatory background process got killed and instance went down. So now I'm gonna, as a DBA job, I need to make sure that my instance is available 24/7. So I'm gonna start that instance now. So what is instance? So again, go back to the definition what I given here. The instance is a combination of your memory and background process. Instance is a combination of memory and background process. In the memory, HGA and PGA, and in the background process, the mandatory and non-mandatory background process. The moment I do startup, I'm gonna start my instance, it's gonna allocate the memory, and then it's gonna start the background process so that end user can connect to this instance and they can able to access data. The moment I do start, you can see all the memory components will be get allocated. Right? So your fixed size, your variable size, your database buffer cache, your redo buffer cache, and your SGA, PGA, all will be allocated, and your database is mounted and your database is got opened. And at the same time, all the background process right here, ps-f devdb. Here it was nothing was running here. ps-f devdb, no background process were running. The moment I start the instance, all the background process will start, mandatory and non-mandatory background process will start, and also the memory will be allocated. So I can show here, show parameter PGA. So we have this PGA aggregate limit 2 GB. Show parameter SG. Again, don't worry about what is this PGA aggregate limit and PGA target. We'll talk in our regular classes. Show parameter SGA. So we have SGA target, which is of 3 GB.
Malik
Right?
sir, can I have a doubt?
Yeah, please.
Actually, you killed S1 now.
Mm-hmm.
How it bring back? How it
I
will bring
started
back?
it, right? It'll not bring back automatically. I
Okay.
started the instance now. You have to start it manually. Without you
Okay.
start, it'll not bring up.
Okay, okay. One more thing. Actually, what is the mandatory components? What is the primary components? How can we know about that?
These are the only mandatory background processes which are needed for your instance operations. Any of these
Okay,
background processes are killed, your instance will
okay,
go down.
okay,
Apart from this, there are like just mentioned non-mandatory background process. Only four I mentioned here. But
okay,
ideally, there's like 20, 30 mandatory, non-mandatory background process you can see here.
okay, okay.
Again, it is not mandatory to know what are these. You have to go to Oracle documentation, and even if you ask me, even I don't know. I need to go to Oracle documentation and refer it because it's
Okay,
not that much or heavily useful or needed. It's internal what instance needs it.
okay, okay. Thank you, sir.
Right. Now I started this one. I just did a startup, and then it has allocated memory, it has allocated buffer cache, it has allocated redo, and it has allocated SGA, it has allocated PGA. How come it is able to start this one? I just given a startup. What is the criteria? How my instance got started? That's the other fundamental story now. Your instance start. Your instance to start, it will read SP file or a P file. Instance to start. I'm just giving here just startup. And then how come who defined this? Who defined this memory component? SGA memory this much and PGA memory this much. Redo buffer cache, log buffer cache, SG your shared pool. Who has defined those memory component? That is defined under this SP file and P file. This SP file or P file is defined with all the parameters. All the parameter meaning your SGA size, your PGA size, and your shared pool size, your large pool size, data buffer cache, your log buffer cache. So there are so many other parameters. I'm just trying to make it simple to understand memory component only. So all these component, okay, my SGA should be let's say 3 GB and my PGA should be 2 GB. My shared pool should be 100 MB. My large pool should be 100 MB. So I can define this memory component in this SP file and P file, and this SP file and P file will be created at the time of database creation. And these SP file and P file are located under Oracle home under DBS location. So if I go here under Oracle home, so I can go with the one of the init file here, init devdb. So in that init devdb, I can define what is my PGA and what are my open class. Again, I'm not going to talk about these parameters, but for now, what is my SGA and what is my PGA? What is my DB block size or DB buffer size or large pool size or shared pool size? I can define everything in this PGA or in this SP file and P file. And this P file and SP file is created at the time of database creation. At the time of database creation, this SP file and P file will be created, and that SP file and P file will be located under this Oracle Home DBS location. And if I don't have this SP file and P file, I will not be able to start my database instance. Whatever I given here startup will never work. The startup will never work. It immediately throw error message. I don't have SP file and P file. So I can quickly show one more time demo. I can kill one more time pmon or smon. Once I kill it, so I'm gonna remove that sp file or p file. So I'm just gonna move this one as a backup file, my init file and the sp file. Now I don't have any sp file and p file. These are the naming convention for the sp file and p file. This is my p file naming convention. Again, we'll talk in our regular classes this naming convention and more detail about what exactly it contains and all. But for now, this is my init file or the p file, and this is my sp file. And again, this is one of the common entry questions. What is sp file and p file? Binary file and text file, and what are the advantages? So you're going to change the dynamic parameters, static parameters. We'll discuss in our regular classes. But for now, to keep it simple, at the time of my database creation, this sp file or p file will be get created. And what is this sp file and p file? This is the parameter file which contains all the database specific or the instance specific information. SGA size, PGA size, DB name, DB unique name. Oh, there are so many other parameters, around 400 to 500 parameters. The properties of my database I'm going to define, and this file will be formed. And any instance to start, you're going to look for the sp file first. If the sp file is not there, you're going to look for p file. If the p file is not there, your instance will never start. Right now, I moved this sp file and p file. I moved it as a backup here, meaning I don't have sp file and p file, and I killed my instance now. Now, if I try to start my instance, it never start. If I go back, connected to idle instance, if I do startup, it says failure in processing system parameters. Could not able to open Oracle Home DBS my init file. That's a P file. So if you don't have SP file and P file, your instance will never start. If your instance will never start and it never allocate a background process or it never allocate memory structure, your instance is not started, meaning it never allocate memory, it never start any background process. If your instance is not started, meaning nobody can able to access my database. That's the fundamental file, a P file or SP file pretty much needed for my instance to start. And the P file and SP file is created under Oracle Home and DBS. Again, what is this Oracle Home? That is, we're going to cover it in our regular classes. That's the Oracle software where we installed it on that server. Under the DBS directory, it will be stored or located. And this SP file and P file will be created at the time of database creation. And then that will be default settings. At the time of database creation, all will be having a default setting. SGA 3 GB, PGA 2 GB. As and when my business grows, more and more users are connecting to my database, I need to increase this SGA and PGA. I can change these parameters. I can make it to 10 GB, 5 GB. So that is a future part based upon need, based upon database user connection. I can keep increasing or keep changing the parameters inside my SP file based upon the need. Once now I can move back, I'll move back my SP file and P file. I'll just move back my P file, the SP file, and I'm going to do just startup. We're going to read this SP file now. According to this SP file, whatever the parameters we defined, SGA, PGA, and other parameters, my instance will get started. It'll allocate the memory and it'll start the background process. If I check the background process now, again, this is your way you can check your background process. The PS is a process list, the background process which started on that server, which had the name DevDB. So these many background process, mandatory and non-mandatory background process, which got collected over here. So now let's say
Malika, I have few queries before we move forward. First of all, what are the minimum mandatory parameters we need to define it in init or
Only
SP file
one.
to start an instance?
Only one DB name.
DB name, right? And what would be the default SG and PG it will take if we start
3
the
GB, 2
instance?
GB. It depends
Okay,
upon your type of database, OLTP or OLAP.
okay. And one thing I want to move back. So you said when the user connects to a database, it gets assigned a PGA process and a PGA memory.
Right.
So what's the default PGA memory a user gets assigned, and
3
how
MB,
much max memory it
3
can
MB,
use,
3
and how
MB.
much max 3 memory
Max
max you
memory will
use?
be based upon your PGA setting.
Okay,
What you defined here, where is the PGA? Right. We have PG aggregate limit and PG target. So PG aggregate limit is the max. You can get 2 GB.
okay. Thank you.
All right. Yeah. Those are like, again, don't worry. Those are the advanced ones. Once we start the first architecture understanding, you will understand all this concept. But yeah, to answer those questions, it is a little bit advanced. Who has already knowledge on the database, be able to ask those questions and able to answer. But who are new, then don't worry at this point. So once we start our regular class, we'll be able to catch up those things what I just discussed. Right. Uh, Now we understood about how instance will get start, and the moment instance gets started, how the a memory will be allocated based on the PGA, based upon the SGA, based upon that P file and SP file, and how that background process will be get started on my OS side. Once that instance got started, a memory is allocated, SGA and PGA, and the background processor got started, and any user who connect to my database can able to access any of data he inserted, any of the data he created. So I can simply go with one user, maybe Malik user. Okay, Malik user connected to that database. Again, I'm using local connection here, but end user may connect using some application, Toad or SQL developer or some application or web application or whatever. So whatever the table this user has, this user Malik user has created some table, student one table. So select star from student. So these are the entries inside the student table: student number, student name, date of admission, fees. So he can go ahead and then further insert the data, or he can go ahead and further delete the data, and he can do whatever he want it. So this is the diagram what I'm talking about here. Let's say this is the Malik user here. Malik user is connected to database now, and the moment he connect, you will get one server process, and he get his own PGA, and then he can do whatever the transaction he want. And this server process is again one more background process. You can see that one here. Let's say a ps-f grep devdb. So these many background process which started on this server, and I can count it how many background process. Right now 52 are background process. So I'll take one duplicate session for this one, the same server, one more session. Right now, let's go to Oracle, and I'm going to do the same connection, the Malik user connection here. SQL plus Malik. He's going to connect to database. The moment he connect to database, let's see the count here. So it become 53. 52 total background process, including mandatory background process, including non-mandatory background process, and including your server process. And now it become 53. One server process got increased. So if I do devdb, and this is the connection here, it says local equal to s. Local equal to s meaning I have connected using this local connection here, SQL plus, from this server. If any user connecting from the application or the web, and that will be having remote. The local connection equal to no, that will be a remote coming from some remote connections. So one server process got added and my count become a 53. And I'm going to exit from that Malik user session. The user exited from the database. Now let's see the count. It become 52. So each of those users connected to my database, they will get their server process, and whatever the query that user is doing, the server process will take that query and execute inside my HGA. It may be insert, update, delete, all will be executed by your server process. And let's say now Malik user connected to my database. He got the server process, he got the PGA, and he connected to my database instance. And he has a student table. The student table has a column, student number, student name, and date of admission and fees. So this student table is the end user data. This end user data will be stored under this data file here. This is the data, actual data is stored here. So Malik user is connected. Now he is reading that data, like whatever we read here, right? Select star from student. The moment I read the data, I can get that entire data here. The end user is doing the select statement. So what this server process will do, server process will go to library cache and go to this database buffer cache and check in the database buffer cache. If the student table is there in this memory, if it is there, it will directly given back to that end user. Oh, I got the data in the buffer cache in the memory. Take, here is the data what you're looking for. The server process will fetch that data. And this is called your cache hit. Again, this is one of your interview question. What is cache hit? Cache hit meaning whatever that end user is looking for the data, that data is available in the memory itself. The student table is available in the memory itself. And then he can get that data. In case if the data is not available in the buffer cache, the server process will further go to data file. And it's going to look for the data files, the physical files. And it's going to look, okay, this is the data file. And in this data file, we have the student table. Let's get that data. And we're going to get that student table from the data file, physical storage, to the memory, buffer cache. And then it's going to give it to that end user. This is called cache miss, meaning the data is not there in the memory. The server process will go further into data files, fetch the table, and put it in the memory, buffer cache, and then give it to that end user. That's a cache miss. And two entry questions you might have faced here. What is cache hit and what is cache miss? And then other entry questions, who is going to bring the data for the end user? That's the server process. Whether it is going to bring the data from the memory itself or whether it's going to bring the data from the data file, doesn't matter. That's a cache hit and cache miss. But who is going to bring the data for the end user? That's the server process, which is started for his connection. That is for the select queries. Let's say the student table has a student number 1, 2, 3. 3 students are registered and all the student entries are there in the student table. And this end user is going to insert, Malik user is connected, he's going to insert student number 4. Student number 4, name is Malik and fees and then date of admission. This is the entry this Malik user is going to insert. And again this select query, in the insert query, this query is taken by the server process and the server process will go to this shared pool and then it's gonna go to database buffer cache and then write this data into this memory here. This block in the database buffer cache is the dirty buffer. Dirty buffer meaning whatever this new record inserted by this Malik user, that new data will be returned to this buffer cache. And then once the server process will write this data in the buffer cache and then it will go back to the end user. Okay, boss, whatever data you inserted, I have written into database. And then your DB writer will come into picture. Your DB writer is one of the mandatory background process The job of the debrider is go and check the database buffer cache, and is there any new data written by somebody? Is there any modified data written by somebody? The moment it get, okay, there is some data written by user, take that block and then write it into data files, and then entry 4 will be added in the physical data file. That's the job of your debrider. The debrider will be keep on looking for dirty buffers, and whatever the dirty buffer found in the buffer cache, it will take those buffers and write into the data files, the physical files. Again, this is one of your interview questions. What is the job of the debrider? Look for the buffer cache, and if there's any dirty buffers, and take those dirty buffers and write into physical files. That's the job of the debrider. Again, when it will write, how frequently it will write, we'll discuss in further classes. But again, other interview questions, what you can get here, what are dirty buffers? Dirty buffers are nothing but any new data or modified data in the buffer cache called dirty buffers. And whatever this transaction happened, select query or insert query, update query, the respective logs will be written into my redo logs. And those transaction information will be written by this log writer process. You will take that transaction information and write into that respective read logs, which are available inside the storage side. Right, that is a overall picture how the transactions or query works. Again, I just explained at high level. I not explained about the SAID pool. Again, in the SAID pool, we have parsing, we have hard parsing, soft parsing, bind variables, and we have this execution. So I'm gonna explain it in our regular classes. But for now, this is enough. Any end user connected to my database, there will be a server process, there will be a PG memory allocated, and whatever the query they do, all will be executed inside my SGA. And three major memory component involved in any transaction is shared pool, database buffer cache, and log buffer cache. So based upon this memory component, your background process, DB writer, log writer, SMOM, PMON, check pointer will frequently try to access your data files, 3D log files, and the transactions will be handled. So this transaction process, what I explained, you have to explain when interviewer gonna ask how the select query works, how the insert query works, how the update query works, how the end users connection is gonna work to my database. Then you should be able to explain this process. But underlining fundamental question, very beginning, what I asked, please explain about database architecture. You should be able to explain about database and instance. That is more than enough. If the interviewer asks, explain about user connection, how the query works, then you have to go to that particular explanation, your SAID process, server process, and your PGA, how the select query works, how the insert query works, and what's the job of the DB writer, log writer. That's the second part of the architecture. You have to explain that. Right. Any questions so far on the architecture part or on the user connections or the query, how it works? Right. So further make it simple.
Malik,
Yeah.
are we going to in depth talking about the DML flow in
Not
the
at this
lectures?
point.
In the lectures.
Yes. In the lectures, everything will be covered. How select query works, how insert query works, how update query works, how delete query works. That will be covered in our regular classes. Right. So now further make it simple. Whatever I explained so far. Right. Let's say my instance. In the instance, we have this memory and we have this background process. Like as I told, end users connect to my instance. You will get a server process. You will get a PGA, and then you'll be connected to my database instance. And we have this buffer cache. Any data is written, you're going to write it over here. And with help of the background process, you're going to write the data here. That is for insert queries. If any select query you do, same thing, you'll go and look for the data here. If the data is not there, and then you're going to go for data file, and data will be written to buffer cache, and then it will be given back to that end user. The same way you can correlate with our normal day-to-day human operations. Like somebody, one of my friend comes and tell me something about some information. So what I can do, I can quickly keep it on my brain for time being, and later what I'll do, I will write into book with help of pair of my hands. I'm going to write into book, and then when this particular book is full, I can take one more book, and then I can write into that one. I can end up with generating so many books. And if somebody comes, or some other user comes, some other my friends comes, and they ask for that information, if I have it in my memory, I can easily answer back to that guy. If I don't have it in my memory, I can go to that book, I can refer that where I written that note, and then once I found it, I can bring it back to my memory and then give it back to that end user. It's the same as how the database architecture works, in just correlation with how day-to-day human life works. So here the memory what we have, similarly my database instance, this instance is nothing but we human, and whatever the memory this instance has, like we human has a memory, and whatever this background process which used to write into book, which used to read the book, the pair of hands is kind of your background processes, and whatever the books were storing the data is your data files. And my database has so many data files. And then is there any limit on this particular book? And some books may be 100 pages, some book may be 200 pages. Similarly, some data files will be 10 GB, some data file will be 20 GB, some data file will be like 30 GB. So we can set the limit on the data files, like how we can set the limit on these books here. So how many books I can write it? No limit. As long as I have books, I can keep writing it. And if the books are full, I can purchase some more books and I can keep on writing. Similarly, for my data files, I can be keep on writing my data files. And if the data files are full, I can add some more data files and I can keep on writing. So these are the questions. Is there any limit on number of DB files? These are the DB files. So answer is no, there is no limit. There is actually a limit in my database. Each database has a 10 to 4024 data file limit. And if you increase that limit, you can add more and more data files. To answer to this question, no limit on the number of data files. Like no limit to books. As long as I can able to purchase many books, I can keep on writing. Is there any limit on the size of the data files? Right now, each data file can be created with a different size. So default 32 GB is a limit for each data file, and you can create data file with a custom size. But answer to these two questions in a real-time word, is there any limit of number of data files? Answer is yes. Is there any limit on size of each data file? Answer is yes. So default is 10 to 4 is the maximum limit of number of data files, and default 32 GB is each data file size limit in my database. But you can create some custom data file size using a big file keyword, and you can increase this limit, and that needs a database restart. After increasing, you can increase that limit. So answer to these two questions is yes, there's a limit, but we can override that. And is there any limit of the size of the data files? Answer is no, there is no limit for the database size. As long as you keep on adding the data file, your database size will be keep on increasing. Like there's no limit for the book size, there's no limit of number of books, and there's no limit for total library what I have it. Similarly, you can correlate here. So number of data files, yes, 10 to 4 is the limit, but you can increase, you can set that limit in the control file, you can increase that one. Each data file size, there's a limit 30 GB, but you can still create some custom file size by big file keyword. And there's no limit for your size of the database. You can keep on adding the data file, your database size will be keep on growing. Right? So that's a quick correlation about database architecture, how we can correlate with your day-to-day human life. All right, let's move on now. That's a simple intro or update on the database architecture and how the end user connection works. And now let's go on one more topic, RAC versus standalone. Again, this particular course is for standalone. I'm talking about only standalone. Standalone is a single node, single instance, single database. RAC is multi-node, multi-instance. So three main advantages: HA, high availability, failover, and load balancing. These are the three main advantages in RAC. It's only available in RAC. So you don't have HA, high availability, failover, load balance in case of standalone. These are the drawbacks with a standalone. Most of the enterprise customer will go with a RAC. So this particular database course is for standalone, not for the RAC. We have a separate course RAC, which is starting this month 28th. So we have demo session on 28 and 29. Feel free to attend that. I can cover a few more basics on the RAC. So let's talk about here now the RAC versus standalone. So this is a simple diagram, self-explanatory. Let's say end users who are connecting via URL browser, or end user connecting through mobile application, or end user connecting through some desktop application. All the end user connection will go to application server. This is your app server. From the app server, all the connection will go to your database. This is your database server and your database instance, and this is your actual database data files. This instance and this data file together will form your database architecture, and this is your server or host where your database is running. All this end user connection, user 1, client 1 connected here, client 2 connected here, client 3 connected. 3 clients are connected via 3 different ways: URL, desktop, or web application. All the connection will go to web server. From the web server, we'll all go to a single host, and we'll all go to a single instance. Let's imagine right now only 3 user connection. Fair enough. If there's a 1000 users connection comes, or if there's a 3000 user connection comes, is the 3000 users are able to handle on this single host? And what happens if this single host goes down? What happens if this single database instance goes down and nobody can able to access my database, the physical data files? That's a drawback. Host goes down, instance goes down. If there are many user connection comes, your server will be overloaded. Let's say in this RAC concept here, if the 3000 user comes, and then 1000 users will be connected to here, and 1000 users will be connected here, and 1000 users connected here. So I have this host 1, I have this host 2, I have this host 3. I have only one database, but I have 3 servers, and I am running instance 1, instance 2, instance 3. All these 3 instances are pointing to single database, the single data files. So 1000 users I can connect to host 1, 1000 users connected to host 2, 1000 users are connected to host 3. That's your high availability, the load balancing. So high availability meaning if one server is not there, you have another server to connect the end users. Right now here one server is not there. Any new user trying to connect, they will not be able to connect. But here any new user comes, they can connect to either node 2 or node 3, or instance 2 or instance 3. There's a high availability. One node goes down, you have a other node to support the incoming connection. High availability. And the load balancing, if there's a 3000 users comes, the RAC can evenly distribute the connection to all the 3 hosts, 1000, 1000, 1000. Load will be equally distributed on all the nodes. So that's your high availability and the load balancing. Both are available. So then the other factor about RAC, let's say I have a user 1 connected over here, the client 1 connected here on this host 1. If this instance goes down or the server goes down, automatically this user connection will go to either instance 2 or instance 3. That's your failover. The rack can support that failover. So that's the other advantages what you can get it in case of rack. The high availability, if one or two rack servers are down, rack instances are down, you have other rack instance to support that incoming connection. The load balance, if there's many users comes at a time, or over a period of time many users are keep on adding or keep on coming to my database, rack has that inbuilt capability. You only distribute that incoming user connection across all the rack nodes, all the cluster nodes. That's a load balancing. And failover, if any users connected to instance 1 or instance 2, if that instance 1 or instance 2 or the host 1 or host 2 shut down or goes down, his connection will be automatically rerouted to other instance. That's your failover. All these features will be available in case of rack, and that's one of the enterprise use case. Any big customers who are like enterprise customers are always run their workload in the rack because of these many advantages. Whereas in case of standalone, we don't support high availability, we don't support failover, we don't support load balancing. All are like no. And in case of rack, it is yes, we have that options. All right. So with that, I'm gonna wrap it up for today. I'm not gonna continue further because if I start explaining, there'll be many topics I can cover. But I can keep it open discussion if anyone has any questions or queries or anything to discuss outside of this topic. I can spend few more minutes. Feel free to ask any of these questions, maybe related to this course or any other technical discussion or any questions, entry questions. Let's spend few more minutes before we wrap it up. Any questions, guys? Right.
I have a question on this rack and standalone.
Yes.
So, how much it will be helpful for this standalone in a rack process, this trading?
Standalone,
All the
no.
processor,
Both
yeah,
are two
all those
different
processes are
courses.
same.
Yes, the underlying process are same. Your instance, all the background process, memory structures remain same. Your database, all the data files remain same. But how we can administrate, that's different. Architecture, fundamental architecture, whether it's a rack or standalone, will be remain same. But how we're gonna administrate, how we're gonna manage, that will be a totally different story.
Okay. So, rack is for HA and other load balancing things. And
Uh,
here we can only,
these are the main feature,
uh,
right? I just explained.
yes, yes.
Yeah.
Oh, thank you.
So if somebody asked, again, it will be one of your common entry questions. How rack is different from standalone? Can you give me few advantages of rack? And what is rack versus standalone? And these are the three main differences: high availability, failover, and load balances. All right.
Okay.
And one or two questions here. So how to get a Google Drive access? Again, there's a question here: how to get a Google Drive access? So this Google Drive access will be for registered student. Feel free to ping me on my WhatsApp number, and you have to make a payment and then register for the course. And once the registration is done, I can grant the access on the Google Drive. I can add you to WhatsApp group, and then you can get the access on the Google Drive. You can watch the recordings. So I have a 16 GB RAM. Is that enough? Yes. We need a minimum of 10 GB. As I told here, if you have 10 GB RAM, that's more than enough for this database course. And for the RAC course, we need a minimum of 20 GB RAM. But for the database course, minimum 10 GB is more than enough. So I have 20 GB RAM. Is that enough for DB and RAC course? Yes, 20 GB RAM is enough for DB and RAC. So you have to open only one lab at a time. Once you are practicing a RAC, you have to open only RAC labs, and you have to shut down them. You are practicing a database, and you have to open the database labs. So 20 GB is, you cannot open both the database and RAC all labs at one time. 20 GB RAM is more than enough. You can complete this both DBA course and RAC course.
16
And
GB is enough for RACs.
no, 20 GB is must. And wait a minute. Okay,
So,
so
Malik,
you need, yeah,
sorry,
go ahead.
Malik. If this batch has to continue with the RAC course, then when you are going to start it with?
This
Any
RAC course
specific
is starting this month end, so new batch will be in probably March.
March? Okay. New batch will be on March. Okay, fine.
Right. So we need plus 100 GB SSD for database course, and here also same thing. We need 20 GB RAM and then 100 GB SSD for the RAC course. Right, and then um so
if
yeah, go ahead.
yeah, if you want to go for a rack course, is this a mandatory training for a standalone or something?
You have to first know your basics. You should be thorough enough in your database admin, because in the case of RAC, we're not going to cover what is SMON, like whatever this architecture I just explained here. What is shared pool, large
Okay.
pool, Java pool, buffer cache. So we'll directly go with the RAC administration. There's a different architecture and concept. So we'll not be covering this database architecture. While explaining about the RAC, and if you're asking what is Java pool, what is large pool, then
Mhm.
that'll be
Little
challenging for
difficult.
you.
Yes. Yes. Oh,
All right.
thank you.
Timing is same, 8:30 to 10:30, or is there any
No, your
possible?
database course is a weekdays, and then RAC is the weekend. So again, you can feel free to go over here on my blog. Okay, we have this 28th December. We are starting this RAC course. You can open this link. So it has all the details. So this is the only weekend batch. So probably you can take a look on this upcoming batch schedule. And also we have that all the Zoom details and Zoom links for the demo sessions. We have two demo sessions, 27 and 28 for the EST time zone, and 28 and 29 Saturday Sunday IST time zone. Timing is going to be same. I just try to attend that. We have a lot of discussion there as well.
Malik, I have one question.
Yep.
How many days we can access these videos?
Again, we
Okay.
answered yesterday, right? These are the lifetime accessible recordings. Right now, if you go back here, I talked about Google Drive. These are the lifetime accessible videos or the
Okay.
material. And not only the lifetime accessible, even you want to download it, you can download it locally into laptop, no restriction on that.
Okay, including with PPT also.
Yes, everything.
Okay.
And again, WhatsApp group also, dedicated WhatsApp group for registered student. It is not
Yeah.
only for only this particular course. Even after completion of this course, you can keep it active and ask any questions, queries, or any
Okay.
support assistant. You can always use the WhatsApp group.
Okay. So this training will be under an Oracle 19C or only
19C.
19C? Okay.
This is what we covered yesterday. This Oracle 19C and live mode and the course fees and the timings.
This training will be based on our real-time activities or like how?
Yes,
Okay.
it's all based upon the real-time examples and real-time demonstrations based
Okay.
upon what is needed for day-to-day activities as a DBA.
Database installation like Oracle software installations, database creations.
Yeah, we covered all this yesterday, right? Probably you missed yesterday's session.
Yes, I did not join actually. I'm in some other meeting in office, that's what thing.
Okay, you can watch the recordings yesterday's one. So it was a good session. So a lot of things we covered there. I can
Okay.
share the recordings. You probably check that.
Yeah.
All right.
We'll do here Oracle client installation also? Oracle
Yes.
19C client.
Yes.
Okay.
That's your chapter number here. Again, this is your yesterday topic, what you missed. If you go with yesterday explanation, chapter number 11, Oracle networking, where you're going to connect with SQL developers or Toad, and for
Yeah.
that you need the client installation.
The application users will ask, right, to install the Oracle client.
Again, this is
separately.
part of this chapter number 11.
Okay.
Malik, in the same one, chapter 6.
Yep.
Is it or and?
Which one?
The sixth one.
This is only 19C architecture.
Okay, so we are not going to see what changes from 11G to 12C and 12C to 19C.
Yeah,
As a-
we're gonna show that one. What are the changes? We have slides for 11G, 12C, and 19C. So best example for your installation changes is this one. Do I have that? No, I don't have it here. So you no need to practice installation and all. Like, okay, we have it here. Good. So this is the changes. What happened? So in 11G, what we used to do? We used to download the software. We used to download that software into U01 patches, and then we used to run the run installer. And that time, run installer used to ask where you want to copy this software. We used to give this path, and then it used to copy from this U01 patches location to this path, and used to create the Oracle home. Whereas 19C, we're going to download the software, and we're directly downloading and unzipping under that 19C grid home. We're going to run the run installer. This run installer is going to make that where you unzipped that directory itself as a Oracle home. So each of them, if you go here, you have this 11G, what are the screenshot? And similarly, if you go with a 19C, what are the screenshot? What are the changes? You can see both 11G and 19C changes.
And I think even memory we need to decide by calculating, correct? In 11G.
No need. Again, I'm talking about only this software installation. For software installation, you don't need of any memory. So once you create a database, DBCA, that's where you need to give the memory, how much SGA and how much PGA.
Like we remember, like we give the SIMA, SHMax, SHMmin.
That's
kind
not
of
a memory. That's a kernel parameters.
Kernel parameters, yeah.
Yeah.
So are we going to talk about kernel parameter?
No need of kernel parameters starting with your 12C.
Yeah.
Oracle
Yes,
provides
yes.
the prerequisites RPMs. You just need to install one single RPM. That's more than enough. In 11G, it was not there. In 11G also, it was not. It was there, but very rare. People never used to install that RPM. All right. So there are a few questions in the chat. I can quickly take it up and then we'll wrap it up. Will you provide the previous batch recordings earlier? That's what I mentioned, right? As part of the course, you will get the previous batch recording and current batch recordings, all the PPTs and all the interview questions. All will be given well in advance. You can watch it by your own.
No, I'm asking about the earlier batches. Means like you have shared the 19th, this batch is 20th batch, right?
Right.
Yeah, the earlier batches and going forward, you'll be conducting some trainings, right? Means
No,
like
there's be your one previous batch recording is more than enough. There will be like hundreds of batch recordings. There are no use of that. If there's any extra topics will be covered, will be kept as a separate directories and will be given access on that one.
Okay, fine. Thank you.
All right. All right. So any last questions, guys, before we wrap it up and move forward? All right. All the best and happy weekend. Let's continue on the regular classes on Monday. Let's wrap it up, guys. Thank you.
Thank you so much.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you all. Bye.